Hi students, today we are going to demonstrate a very simple experiment in physics, namely simple pendulum. Now what is the aim of the experiment? To determine the acceleration due to gravity g in a place using a simple pendulum. So what is the formula used? G equal to 4 pi square into L by T square mean, where L represents the length of the pendulum in meter. Capital T represents the period of oscillation in seconds. And small g represents acceleration due to gravity, that is in meter per second square. We have used in the theory class that small g is equal to approximately 9.8 meters per second square at a latitude of 45 degree at sea level. Is it not? Now we want to derive that value using a simple pendulum. So what is the observation table you have to make? Like this. There are some columns. The first column is serial number. The next column is length of the pendulum in meter. So we are going to take a different length of the pendulum. For different lengths, what we are going to measure actually? The time taken small t for 10 oscillations we are going to measure, because quickly the pendulum will go and return back, so that the time is very short. So we will take 10 oscillations time taken, and we call it as a trial 1. And to confirm that, one more trial we are going to take for the same length for 10 oscillations. And the average of these two, trial 1 and trial 2 for 10 oscillations, we are going to consider here in seconds. Then if the time t for 10 oscillations is divided by 10, what you get is a time taken for one oscillation, that is called as period of oscillation, capital T. So that must be equal to small t for 10 oscillations divided by 10, that is in seconds. Then we calculate the square value of t square and write in this column, that is in seconds square, period square. The last column is L by t square. So L is in meter here and t square is in second square. So L by t square must be in what? Meters per second square. So for different lengths, we find out what is the value of L by t square and find the mean value of this L by t square and substitute in this formula. Okay, now let us demonstrate by taking the experimental apparatus. So this is a vertical stand in which a simple pendulum is suspended with the help of a rubber cork, a split rubber cork. Okay. Now the point where it is suspended is called the point of suspension. It is at the top, and the length of the pendulum is measured from the point of suspension up to the center of gravity of the bob. So this is the bob. Now we cannot measure using a scale from the center of the bob. Therefore what we will do, we will measure the length of the pendulum from the body of the bob up to the point of suspension. Assuming the radius of the bob is approximately 1 centimeter, okay, the distance from the body or material of the bob up to the point of suspension is taken as 39 centimeter. So 39 plus radius 1 centimeter makes now the length of the pendulum as 40 centimeter. So we have measured using the measuring scale. Okay. Now we have constructed a simple pendulum of length 40 centimeter. So in meters I have written it as 0.4 meter. Okay. For this I want to measure first the time taken for 10 oscillations. So using a stop clock, okay, using a stop clock, I want to measure the time taken for 10 oscillations. So for that, what is very important, this expression is true only for small amplitudes. Okay, you cannot take the pendulum over a large amplitude and do this experiment. You cannot. With respect to the equilibrium position or mean position, the angular displacement okay, made by the string must be very less. Okay, very less. That means this must be the angular position of the extreme position. So from here only we should oscillate the pendulum. Very small oscillations only will be perfect. So large amplitude oscillations if you do means then the value of G may not be perfect. So avoid taking large amplitude oscillations and small amplitude oscillations only you will have to take. Understand, like this. So whenever the pendulum is oscillated, you can take any one fixed position and from there you start the clock. Okay, don't start the clock when the bob is between the extreme positions. Perfectly if you do means, see here, I take that now the pendulum is taken to the extreme position and from here it is dropped. Okay, from here it is dropped. So I can set the clock ready like this, and whenever it is coming towards my right, I am going to start the clock. You see here, when it comes towards my right, I will start the clock. Okay, start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When it has completed 10 oscillations, I will have to stop the clock first. Don't bother about the oscillating pendulum now. Now first you have to stop the clock. So what is the time taken for the 10 oscillations I have measured is 13 seconds. Okay. So I will now record the trial 1 time taken for 10 oscillations is 13. Okay. So our trial 1 observation is over. Now I have to reset the clock. For that, here one knob is there, so I am going to reset back to 0. Okay. Then once again I have to repeat it for 10 more oscillations for the same length. So I told you that the extreme position should have an angular displacement very small, less than 5 degree to 10 degree we will say. So from here you have to make it oscillate freely, free oscillations like this. Okay. So free oscillations. Once again I am going to start the clock when the bob turns towards my right side. Okay. So I have started 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after 10 oscillation I have to stop the clock. Now once again you see that it has taken 13 seconds. Suppose if it takes 12 seconds also, you need not worry. Whatever time you have recorded, you note it down. Because the third column you are going to take the average of the 2 trials. Is it not? Anyhow, for me now 13 seconds I have noted. So this is 13 seconds for 10 oscillations. Since both are 13, the average should be what? 13 plus 13, 26 divided by 2 is 13 only. So the average time taken for 10 oscillations is what? 13 seconds. So what is the period of oscillation for one oscillation? It is 13 divided by 10. So that is what? 1.3. Okay, 1.3. So this is the time period for one oscillation. For a simple pendulum of length how much? 0.4 meter, that is 40 centimeters. Now here there is a column T square. For my convenience, I will calculate what is T square and record it in a separate column. So it is 1.3 the whole square. So 13 13s are 169, is it not? Therefore 1.3 must be, the square of 1.3 must be equal to what? 1.69. So here I will write the T square column is what? 1.69. Okay. Now I will do a rough calculation here. Okay, see here. Now the calculation I will do it for the first length. So how to do the calculation? So first one is what? L. So L is equal to 0.4 meter and the corresponding T square is equal to what? 1.69 second square. Therefore, G is now equal to 4 pi square into L by T square. So this is equal to 4 into 3.14 the whole square into L by T square. So this is what 0.4 divided by 1.69. So this calculation, let us use a calculator, okay? So the last column, one more column is there, that is L by T square. So for that L is 0.4, okay, 0.4. So 0.4 divided by 1.69. So this is coming as 0.236. So 0.236. So this is 4 multiplied by 3.14 whole square. 3.14 whole square. Okay. So 3.14 multiplied by 3.14 is 9.86. So 9.86 into 0.236. So I want to find the value of G by multiplying these three numbers. So this is 4 multiplied by 9.86 multiplied by 0.236. So this is coming as 9.307. 9.307 is coming. So I can round this off as what? 9.31 meters per second square. So this is how to find the value of G. For only one trial I have shown an example. Actually you are supposed to do what? You have to proceed for the next length 0.5 centimeter, okay? Then 0.6 centimeter. Then for them you have to take trial 1, trial 2 like that, okay? And finally you will have to fill up the column L by T square for a different length. So then you have to find the average value of L by T square. Okay, this is the first calculation, only one I have done here. Another method is for every length you can find the value of G also. Okay, this is another method. Okay, so for every length you can find the value of G, and finally you can take the average of the value of G also. Now I will change the length of the pendulum for what? 50 and 60 centimeters. So I told you, my dear students, first observation for 40 centimeters length we have calculated the time. Okay, like that when you repeat it for 50 centimeter and 60 centimeter respectively, you will get the period for oscillation as 1.45 second and 1.6 seconds respectively. Then you take a square value of T. So that T square column you will have to fill it appropriately, and then find the value of L by T square. Now in CBSE schools for class 11, every time you will have to find out the value of G and take the average value of G and write as the result. Now in the state board Tamil Nadu especially, we are doing for different length L by T square calculation we will do it, and we will find the mean value of L by T square. See, for these three observations, what is the mean value of L by T square I am going to find out. So that is the sum of 0.236 plus 0.238 plus 0.234 whole divided by 3 I have shown. If you do 5 readings means divided by 5, okay. So here it is divided by 3. So that it is 0.708 by 3. We get the average value of L by T square as 0.236. So as per the given formula, the acceleration due to gravity G must be equal to what? 4 into pi square. That is 4 into 9.86 multiplied by the mean value of L by T square is what? 0.236. So if you multiply, what we are getting is what? 9.31 only. You need not worry that it should be exactly 9.8 like that, okay. There are so many possibilities of errors. We have studied random errors will be there due to the external wind, the weather conditions, and the height where you are doing the experiment. So you can eliminate the error and get the actual value inside our physics lab is how much? 9.31 meters per second square. So finally what you are going to write in the result, okay. So the value of acceleration due to gravity in our laboratory under the regular conditions is 9.31 meters per second square. Now, whatever readings we have already taken in the observation table for L and T square, I have summarized once again. This is for drawing the L versus T square graph. So, we took the three different lengths 0.4, 0.5 and 0.6 meter. The corresponding T square value I have written. Now, a graph has to be drawn by taking the length along the x-axis and T square along the y-axis. So, L in meter is taken along the x-axis, T square in second square is taken along the y-axis. Now, whenever you draw a graph, you will have to take a suitable scale, that is scale along the x and y-axis. So, along the x-axis, I represent each 1 centimeter. Each 1 centimeter is equal to 0.2 meter, as you like. Okay, you can take each 1 centimeter is equal to 0.1 meter also. Okay, so I have assumed that 1 centimeter along the x-axis indicates 0.2 meter. Similarly, along the y-axis, each centimeter I have represented about 1 second square, depending upon the minimum value and the maximum value. Okay, so our minimum value is 1.69. So to accommodate that, I have shown that minimum value on the graph is 1. So 1 up to 5 I have taken, okay, along the y-axis. Now, suppose if I have taken 5 readings or 6 readings, for example, I have shown 5 points on this graph, okay. Out of these 5, only 3 points are coming along a straight line. So, maximum points should be accommodated on a single straight line. So, I find that these 3 points are lying on the same straight line. So, I join that through the origin, the graph is continuing, okay. So, 2 points are outside the graph, we need not bother about them. For this straight line graph passing through the origin, out of the 3 points lying on the graph, any 2 points I need to find the slope of the graph. So to find the slope of the graph, we take 2 points, okay. Namely, I will take here, this point is A and this point is B, okay. So I project these points A and B on the x-axis as well as y-axis. Can you see that the projection of the point A on the x-axis is lying between point 2 and point 4? Similarly, the projection of the point B on the x-axis is very close to point 6. So, this difference along the x-axis is called as the x-intercept. X-intercept is denoted by what? Delta x. For example, here it is 0.6 minus 0.4 meter. Okay. So, delta x is called the x-intercept of the graph. Similarly, I project the points A and B on the y-axis and find the difference delta y, which is called as the y-intercept. In this, I have shown it is 4 minus 2, for example. Understand, whatever readings we have taken, accordingly the slope differs from person to person. So, for your understanding, how to draw the graph is like this. So, my dear students, how to find the slope of any graph? So, here slope of the graph is equal to the y-intercept divided by a x-intercept. So, along the y-axis, what we have taken is t square. So, I will write this is t square divided by x-intercept is length. Okay. So, slope is equal to what? T square by L. Therefore, we take the reciprocal of the slope. 1 by slope is equal to L by T square. For example, I am getting, say this is 0.245. Okay. The slope is 0.245. I am getting, for example. Okay. Then from graphical method, G is equal to 4 into 3.14 whole square, okay, 4 pi square into 0.245. So that this is equal to 4 into 9.86 multiplied by 0.245. So this value L by T square by experimental method from the observation table, whatever we have got, closer to that value it will come. Now, for example, I have taken, if you get differently from the observed value also. For example, if you get 0.2 245 means then it is 4 into 9.86 into 0.245. So this is equal to 9.66 meters per second square. So by experimental method you must have got a different value, and by graphical method you must have got a different value, maybe very close to each other. So in the result what we are going to write, by the experimental method we have got 9.31 meter per second square. By the graphical method you have to write that G equal to 9.66 meters per second square. Both sometimes may be equal also. Okay. So first we have arranged the experimental setup, and we have taken a string. The length of the string is 1 centimeter than the actual length of the pendulum, because the radius of the pendulum is nearly equal to 1 centimeter. So we started with 39 plus 1 40 centimeter, then 49 plus 1 50 centimeter, then for 60 centimeter 59 string length plus 1 centimeter radius of the bob. So we did the experiment for 10 oscillations. Trial 1 and trial 2 we have taken the time. For 10 oscillations we took the average and divided it by 10, so that you will get the period of oscillation. Then find out t square value, then divide the length of the pendulum L by the t square value and make a column L by t square. So there are two methods. The average of all L by t square you can take and do one calculation for G, or you can do for every calculation G value you can find out. Finally you have to take the average of the 5 or 6 values of G you have taken. So after doing that, graphical method you have to do it and write the result in 2 points. I hope you must have understood well. Fine.